All right, back again, 2.3, real zeros of polynomials. So this lesson, we're going to show how to find zeros. We're going to use long division. We're going to use synthetic division. And so let's just get started. So let's just review how to use long division in a simple division problem. So if you have 23 goes into 23 one time, and you put that 1 above the 3, and then you would take 1 and you would multiply it to that number, and it gives you 23. And then you subtract, and that's the same thing as plus the opposite, which gives you 0. And then you bring down the next number, and then you would say, what do you multiply 23 by to get 0? And so then you have 0 again. You take 0, you multiply it to 23, you get 0. You add the opposite, and then you're going to bring down the 2. And what do you multiply 23 by to get 2? 0. And then you subtract or add the opposite, bring down the last number. What times 23 is 24? It's 1. You take the 1, you multiply it to the 23. You get 23. I'm out of room. You add the opposite or subtract, and you get a remainder of 1. And we can write the answer as 1001. You can take the remainder and put it over the divisor. And so there's your solution. Long division is not really much different. So you take the first part and put it under the house, just like you did up here. However, you want these to be in descending order, x to the 4th, x to the 3rd. Notice we're missing x squared. So plus 0x squared plus 11x subtract 7. So I went ahead and I added in the plus 0x squared. I'm dividing by x plus 3. Now what I like to do is hide everything except for the front two numbers. So what I mean by that is I'm going to look at the x, and I'm going to look at the x to the 4th. And that's all I'm going to look at right now. So I say to myself, x times what is x to the 4th? And I know that's x cubed. So because this is a binomial, we would put this over the second term. This would be x cubed. And then you take the x cubed and you multiply it to both of these numbers. So x cubed times x is x to the 4th. These are always identical until you subtract or do plus the opposite. And then you have x cubed times 3 is plus 3x cubed. Now from there, we're going to subtract, or we're going to add the opposite. And I like to do it that way, adding the opposite. So if you did it right, these first terms are always going to cancel. So x to the 4th and negative x to the 4th is simply going to cancel out. Then you have negative 8x cubed and negative 3x cubed, and that's negative 11x cubed. And then just like I did up here, I bring down the next number, and then I'm only going to focus on the front. So x times what is negative x cubed? And that is a negative 11x squared. Then you take negative 11x squared and you multiply it to both of these. So negative 11 times x is negative 11x cubed. Again, you want these to be identical. Negative 11x squared times 3 is negative 33x squared. Yeah, negative 33x squared. Now, instead of subtracting, so here's subtract, we are going to do plus the opposite. These will always cancel. 0x squared plus 33x squared is 33x squared. All right, from there, let's see if we can move this up a little bit. Come on, this is videotaping. We don't have a lot of time. All right, there we go. So let's look at what we have next. So this time I'm going to bring down the next number, which is plus 11x. And then I'm only going to look at the 33x squared and the x. And I say x times what is 33x squared? And so that is going to be plus 33x. Multiply 33x to both of these. 33x squared. These are identical. 33x times 3 is 99x plus 99x. Okay, we're going to subtract, which is the same thing as add the opposite. Those cancel. 11x subtract 99x is negative 88x, I think. So negative 88x. From there, we're going to bring down the negative 6. Focus on just the front number and say x times what is negative 88x. And that is simply negative 88. So this is negative 88x when I take negative 88 times x. And negative 88 times 3, let me look, is 264. Then we're going to change the sign. So subtract is plus the opposite. Those cancel. Negative 6 plus 264 is a remainder of 258. So now what you do is your answer is this when you divide plus the remainder of 258 over what you divided by, x plus 3. And this is called long division. Now, sometimes you don't have a choice and you have to use long division. But if you're dividing by a binomial, you can also use what's called synthetic division. And we will be doing that during this lesson. So the remainder theorem is super cool. The remainder theorem is really neat. It says if f of x is divided by x minus k, so k is representing some number, right? Then the remainder is going to equal f of k, as if you were going to plug that number in. So let's look at this. Find the remainder. So just looking at the remainder only. If you're using division and you're going to take this polynomial and divide it by x plus 3. So the first thing you have to do is figure out what k is. So do you notice that this form is x minus k? So x minus k. I gave you x plus 3, so it's not quite in the right form yet. It would be x minus 3. And so now you can see that my k is going to be -3, right? So k is -3, and so we're going to find f of -3, all right? And so what we'll do is we'll take the polynomial function, and everywhere I see an x, I'm going to put in -3. And this is going to give me the remainder if I were to divide x plus 3 into this polynomial function. So if I have x to the 4th, let's just go ahead and write the -3 there. So -3 to the 4th power, subtract 8 times -3 cubed plus 11 times -3 subtract 6. And when I solve this, if I were to use long division, this is going to be the remainder. Now, the reason why this is important is because if my remainder is a 0, then I know it divided evenly. And if it divides evenly, then I would know that x plus 3 is a factor. All right. So let's come here. -3 to the 4th is +81. Subtract 8 times -3 cubed is -27. Subtract 33, subtract 6. And looking at this, you could throw it into your calculator. You're going to get 258. So when I did f of -3, it equaled 258. 200 and my pen's going crazy. 258 is also the remainder. So let's look at example 2b using the remainder theorem. If I give you that I'm dividing by x plus 1, then k is going to equal -1. All right, so let's take -1 and plug it into the function. So this is 3 times -1 to the 202 power, subtract 7 times -1. I don't know what that storage optimization is. To the 13th power, subtract 8. Now, something to remember is if you have a -1 and you raise it to an even power, then it's going to stay positive because a negative times a negative is a positive. So this is the same thing as 3 times +1. If you take -1 and you raise it to an odd power, it's going to stay negative because you're going to have a negative number of negative signs, or an odd number of negative signs is what I'm trying to say. And then subtract 8. And so 3 plus 7 subtract 8 is 10, subtract 8 is 2. So what is the remainder when I take this and divide it by x plus 2? The remainder happens to be 2. So looking at example 2c, we're going to use long division. And do you see that this is missing a plus 0x? So underneath, we're going to have 2x cubed subtract 3x squared subtract 5x plus 6. I made sure those were in order. X to the cubed, x to the third, x to the second, x to the first, and the constant term. And then we're going to divide it by x squared plus 0x subtract 3. And then what I like to do is just look at the x squared and just look at the first term and ask yourself, what do I multiply x squared by to get 2x cubed? And that's going to be a 2x. Now, you're going to put the 2x way over here because there's 1, 2, 3 terms. So you place it above the third term. Then you take the 2x and you multiply it to all three of those. So 2x times x squared is 2x cubed. Again, you want these first terms to be identical because when I subtract, they'll cancel. And then 2x times 0 is just, you can just write this as a placeholder if you would like. So it's going to be plus 0x squared. And then 2x times negative 3 is negative 6x. So I really like that placeholder. It just helps me organize everything. So subtract is the same thing as plus the opposite, opposite, opposite. Now, the front terms are going to cancel. I am left with a negative 3x squared, a subtract 5x, and a plus 6 when I bring down the next number. Again, ignore everything looking at just the negative 3x squared and the x squared. And x squared times what is negative 3x squared? And that's going to be negative 3. So subtract 3. Take that negative 3 and multiply it through to everything. So now I have a negative 3x squared, and then times it by 0 is just going to be subtract 0x. And then a negative 3 times a negative 3 is a 9. And then don't forget you're subtracting that, which is a plus the opposite, opposite, opposite. These cancel. A negative 5x is going to stay as negative 5x. And then 6 subtract 9 is negative 3. And maybe I did that wrong because negative 5x plus 6x is 1x. Oh, goodness. All right, so let's just fix that really fast. Help me out, everyone. So this would be plus 1x, and 1x plus 0x is x. Subtract 3. Yay, goes to show. You can fix your mistakes. All right, so my answer is 2x subtract 3, and then I'm going to add the remainder, which is x subtract 3, over the divisor, which is the x squared subtract 3. I don't need to put in the 0 placeholder there. And then here we go. You guys could have caught my mistake, but I caught it right at the end. Okay, let's move on. Factor theorem. So the factor theorem is if x minus k is a factor of f of x, then if and only if f of k is equal to 0. So that's how we know it's a factor. So let's try that theorem. Determine if x minus 3 is a factor of this without dividing. So without dividing, we are going to use our factor theorem. So k, what is k? Well, this is x minus k. So you have an x, a minus, and you can see k is right here. It happens to be 3. So you're going to find f of 3. And if f of 3 equals 0, then x minus 3 is a factor. So 2 times 3 cubed, subtract 3 times 3 squared, subtract 5 times 3, subtract 12. So you're going to throw that all in, and you're going to see when you're done that that is equal to 0. So since f of 3 is equal to 0, yes, by the factor theorem, x minus 3 is a factor of that. All right, let's look at example 4. So example 4, it says find f of 2. So there's two ways to find f of 2. The way that we're used to doing it is everywhere we see an x, we plug in the number 2, and that would tell me what f of 2 is. But there's also a way to do this with synthetic substitution. It is super cool. So the first thing you do is you look to make sure that you're in descending order and that you're not missing any terms. So it goes x to the 4th power, 3rd power, 2nd power, 1st power, and then the constant term. It's kind of like your Aggie cheer. So you would do 4 claps in a cheer, 3 claps, 2 claps, 1 clap, and then go Aggies is going to be your constant term. All right, so if you're looking for f of 2, 2 is k. So you put k in the box, and then you're going to write the constant, the coefficients in front. So the leading coefficient is -3, and then you have a 1 in front of the x cubed, a -5 in front of the x squared, a 6 in front of the x, and then a 1 for your constant term. You bring down the first number, which is -3, you multiply it to the box, and then you add. You multiply it to the box, and then you add. You multiply it to the box, and then you add. So -24. Multiply it to the box, -48, and then add, -47. I'm super tired. I hope I added right. All right, so what does f of 2 equal? According to the remainder theorem, it's this last number here, which is -47. So what that means is in this polynomial function, when I look at the graph, when I go right to, I'm going down to -47. In the interest of time, I'm going to let you try this one on your own. You can stop the video and then pick up and see if you did it right. So looking at this problem here, k happens to be -3, so you should have put -3 in the box. A really common mistake is students forget these 0 placeholders. So notice I did 5 claps. So 5, I'm missing 4. So here's the 0, x to the 4th. And then I have 3 claps, 2 claps. I'm missing the 1. So here's 0, x to the 1st power, or your 1 clap, if you want to think of it like a cheer, and you always have to clap in order. 5 claps, 4 claps, 3 claps, 2 claps, 1 clap. And then you also always need the constant term. That's the Go Aggies part of the cheer. Remember that you bring down the first number, and then multiply to the box, write it down, and add. You go through the process, and the last number is going to be -137. So f of -3 is equal to -137. So if I asked you, if k is -3, then if I did x minus k, that would be x minus -3. So if I said, is x plus 3 a factor of that polynomial function, you would say no way, because there's a remainder there. If that last number is 0, then yes, it would be a factor, which means that you would have a 0 there. And my battery's low. I don't know if you keep hearing that. So I'm going to have to recharge my battery for a moment.